All right, let's dive in. Anyone out there prepping for the CCSP exam?
Absolutely a crucial cert for sure.
Today we're getting into hardware and virtualization security, and we're going deeper than just surface level definitions.
Gotta understand the how and why, not just memorize terms.
Exactly. Think of this as your cheat sheet for really grasping these concepts so you can confidently secure any cloud environment.
That's the goal, right? Secure those cloud environments.
Okay, let's start with the very beginning, that moment when you power up your computer. What happens even before your operating system loads?
You're talking about the BIOS, right?
BIOS, yes. But why are we talking about something so, I don't know, fundamental when we're dealing with the cloud? It feels almost too basic.
Well, because securing the cloud means securing every single layer, and that includes the hardware, the most basic layer. And the BIOS is, well, it's essentially the king of that layer.
Okay, I'm listening.
Think about it. The BIOS is the first thing that runs when you boot up. Checks your hardware, starts loading the operating system, but it can't be stored on your hard drive, right?
Why not?
Because the hard drive needs the BIOS to even function.
Ah, okay, that makes sense. Bit of a chicken and egg situation.
Exactly. So where does it live then? That's where firmware comes in. It's software, but it's embedded in the hardware on a chip, so it's there, ready to go as soon as you power on.
Makes sense. But I have a feeling there's a but coming.
There is. See, that accessibility, while great for functionality, makes it a prime target. If an attacker can mess with the BIOS, they could control the whole system.
Okay, that does sound a little terrifying. Like a hidden backdoor built right into the foundation of a house. So what can we do to, prevent that?
That's where UEFI comes in. Unified Extensible Firmware Interface. Basically, it's like BIOS 2.0, designed with security in mind. It uses something called Secure Boot.
The secure boot, all right.
Secure Boot verifies that the firmware is, well, legitimate, hasn't been tampered with before it runs. Think of it like a digital fingerprint.
Ah, I see. Checking the fingerprint against a known good copy.
Exactly. If the fingerprints don't match, Secure Boot knows something's up and stops the boot process.
That is a relief. But we're still dealing with a lot of sensitive stuff during that boot process, like encryption keys.
Very true.
How do we protect that information?
That's where the Trusted Platform Module, or TPM, comes in. It's a special chip that acts as a vault for that kind of sensitive data.
Oh, vault, okay.
It stores encryption keys and protects them, even if someone steals the whole hard drive. So think of the TPM as the security guard for your sensitive data, at least at this level.
All right, so we have UEFI verifying our boot process and the TPM protecting our sensitive data. Feels like we're building a fortress around our hardware. Are we done? Is that all we need to worry about in cloud environments?
It's an excellent start, for sure. But we can't forget that the hardware layer goes beyond just the BIOS and TPM. We have to consider all the components involved in sensitive cloud operations.
Give me some examples.
Well, things like network controllers, your storage controllers, specialized processors, even the physical storage media itself.
So anything that interacts with sensitive data is a target.
You got it. And that means we need some serious security measures across the board. Things like supply chain validation. You need to trust that the hardware you're using hasn't been tampered with before it even gets to you.
Wow, yeah. Imagine if someone, I don't know, stuck a back door into a network card before it was shipped out. That's a scary thought.
It is, and it happens.
So it sounds like we have to treat every piece of hardware like it's a potential vulnerability. What are some ways to mitigate that risk? What can we do?
Well, on top of supply chain security, you have to be diligent about driver verification, keep your firmware updated, configure all those security settings properly.
It never ends, does it?
It's a constant battle, for sure. Attackers are always looking for weaknesses. But luckily, there are some tools that can help us.
Okay, I was hoping you'd say that.
And one that stands out, especially for cloud environments, is the Hardware Security Module, or HSM.
HSM. Wait, didn't we already cover protecting sensitive data with the TPM?
We did, but HSMs are a whole different level.
All right, now I'm intrigued. Tell me more. What makes them so special?
Think about all that encryption and decryption we've been talking about. It involves a lot of complex mathematical operations. And that's what HSMs are built for. They handle these cryptographic operations quickly and, most importantly, securely.
So they're like super calculators for those complex algorithms.
You could say that, but what makes them really unique is how they manage encryption keys. They do it without ever exposing those keys to any single person.
That's smart.
Right. It drastically reduces the risk of compromise, offering a level of security that's hard to match.
So do cloud providers use these HSMs themselves, or are they something that customers can use too?
Both, actually. Cloud providers use them to protect their own infrastructure, but they also offer them as a service to customers who need that extra level of protection for their sensitive data.
So if you're dealing with, I don't know, really confidential information in the cloud, HSMs are the way to go.
They're definitely worth considering.
Now, when we talk about evaluating how secure these HSMs are, especially in a cloud setting, how can we be sure they're up to par? Are there any standards or benchmarks to look for?
Great question, and yes, there is. In the US, we have FIPS 140-2.
FIPS 142, what does that stand for?
Federal Information Processing Standard. It outlines really strict requirements for cryptographic modules, including HSMs.
So FIPS 142 is like a seal of approval telling us an HSM meets certain security standards.
Exactly. And it's not just a pass or fail thing. It actually defines 4 different security levels.
Oh, those okay.
Each level demands more and more stringent requirements. Think of it as a rating system, with level 1 being the most basic and level 4 requiring the highest level of protection.
So even if FIPS 142 is specifically for U.S. government agencies, it's a useful benchmark for anyone looking at HSM security, right?
Absolutely. It's globally recognized.
Got it.
And understanding it can give you a real advantage when you're evaluating different cloud providers. Look at what FIPS level their HSMs have. It'll tell you a lot about their overall security.
Great tip. Okay, so we've covered a lot of ground here, from biosecurity to these super powerful HSMs.
Hardware is a big topic, that's for sure.
It is, and we're talking about the cloud, which is all about virtualization.
Yeah.
So how does virtualization change things in terms of security?
That's the question, isn't it? And it's what we'll be getting into next. Virtualization brings a whole new layer of complexity that we need to understand. So virtualization, it's all about getting the most out of your hardware. You're running multiple virtual machines on a single server.
Right, makes things more efficient.
Exactly. But more efficiency can also mean more security challenges.
Yeah, that makes sense. Sharing resources always sounds a bit risky. What if one of those virtual machines gets compromised? Could it affect others on the same server?
That's a smart question to be asking, and the answer is yeah, it's definitely possible.
Okay, so how do we stop that from happening? How
Yeah.
do we prevent one bad apple from spoiling the whole bunch, so to speak?
Well, it's kind of like physical security. You need layers. We've already talked about securing the hardware itself. Those same ideas apply here. Make sure those virtual machines are configured correctly, keep them patched, harden them against attacks.
Right, basic security hygiene.
Exactly. And you also have to keep an eye on resource usage. If one virtual machine starts hogging all the CPU or memory, it can cause problems for the others.
Makes sense. You don't want one tenant in your apartment building using up all the hot water.
Good analogy. But we also need to consider the hypervisor itself.
The hypervisor, right?
The brains behind the whole virtualization operation. It sits between the hardware and the virtual machines, managing all the resources.
Okay, so we need to secure the hypervisor too. But isn't that similar to managing a physical server?
You're right, a lot of the same principles apply. Keep the software updated, configure the security settings right, and monitor for any suspicious activity. But with a hypervisor, there's an added layer of complexity because it's dealing with multiple virtual machines at once.
Right, it's like a security guard who's responsible for multiple buildings instead of just one. More to watch over, higher stakes if something goes wrong.
Exactly. And that brings us to another interesting point. Virtualization can actually affect how our traditional security controls work.
Really, how so?
Well, think about a firewall. You have it set up to control traffic between different zones on your network, but what if the virtual machines are communicating directly within the virtualization platform?
They'd be bypassing the firewall completely.
Yep. Your firewall might not even see that traffic, let alone control it.
That's a bit concerning.
It is. It shows how we need to adapt our security approach for virtualization. You can implement virtual firewalls right within the platform, or make sure all traffic between security zones goes through the physical network where your regular security devices can see it.
It's all about adapting to the way virtual machines communicate, making sure nothing falls through the cracks.
Precisely. And speaking of visibility, are there any tools that can help us manage all of this? Virtualization can get pretty complex, lots of moving parts.
Lots of virtual machines, networks, storage. It does sound like it could be a lot to handle.
It can be, but every virtualization platform has its own management tools. They give you a central view of all your virtual resources. You can monitor performance, allocate resources, move those virtual machines around, even enforce security policies.
So it's like a control panel for your virtual world.
You got it. But what about tools for individual virtual machines?
Is there something for that too?
There is. We have something called guest operating system virtualization toolkits. Think of them as little helpers you install inside each virtual machine.
Helpers. Okay. What do they do?
They let the hypervisor communicate directly with the guest operating system. Gives you much more granular control.
Interesting. Can you actually enforce security policies inside the virtual machines themselves?
You can. We can use them for all sorts of things, enforcing policies, running scripts, collecting logs, monitoring activity, even remote management tasks. They're your eyes and ears inside each virtual machine.
So we have security at the hardware level, the hypervisor level,
Yeah.
and now even inside the virtual machines themselves. That sounds pretty comprehensive.
It is. Securing a virtualized environment takes a multifaceted approach. You have to think about all the pieces and how they interact with each other.
And we can't forget resource management,
Yeah.
right? It's not just about preventing attacks, but making sure everything runs smoothly.
Absolutely. But all this talk about virtual machines and hypervisors raises an interesting question. How does that shared responsibility model work when we're talking about the cloud? Who's responsible for what?
That's a good question. It's not always clear where the cloud provider's responsibility ends and the customer's begins.
And that, my friend, is a topic for our next segment.
So where do we draw the line? When we talk about virtualization in the cloud, who's responsible for what? Cloud provider versus customer.
The shared responsibility model. It's a big one, especially for the CCSP exam. It means both the cloud provider and the customer have a role to play. It's a partnership.
So it's not as easy as just saying, oh, the cloud provider handles all the security.
Not at all. It really depends on what service model you're using, right? IIS, PaaS, SaaS, they each have their own nuances. But in general, the provider is responsible for securing the underlying infrastructure, the hardware, the hypervisor, the network.
So they handle the, I don't know, the foundation of our virtual apartment building, the walls, the plumbing, all that.
Exactly. But the customer, they're responsible for everything they bring into that cloud environment. Their virtual machines, the operating systems, the applications, the data.
So even though the landlord takes care of the building security, the tenant is still responsible for locking their own door and keeping their belongings safe.
Perfect analogy. It's shared responsibility. Both sides have to do their part. So let's take IS, for example. The provider handles the physical security, the hypervisor, the networking. But you, as the customer, you're responsible for securing those guest operating systems inside your virtual machines, managing who has access, and making sure you have the right security controls for your applications and data.
Sounds like a lot to keep track of. What are some of the, I guess, the key areas we should focus on as customers to make sure we're meeting our end of the bargain?
Well, we've already talked about a lot of them. You've got your secure configuration of those virtual machines, patching, vulnerability management, strong access controls. Those are all crucial. And don't forget data encryption. If you're storing sensitive data in the cloud, it needs to be encrypted both while it's moving and while it's sitting there.
It seems like a lot of these security best practices are pretty universal, whether you're dealing with a traditional data center or a cloud environment.
You're right. The principles are the same. But the context and the tools you use, those might be different. You might be using cloud-specific security tools to manage access, monitor activity, and detect threats. And remember, those virtualization toolkits we talked about, they can be a big help for enforcing security policies within the virtual machines themselves.
Right, those little helpers.
Yeah.
Are security agents inside each virtual apartment. But managing all this, especially in a large cloud environment, it can feel overwhelming. What are some strategies to, I don't know, make it more manageable?
One word, automation.
Automation.
It can be a game changer. Imagine if you could automatically scan for vulnerabilities, enforce policies, even respond to incidents, all without having to lift a finger.
That sounds amazing. Frees up the security team to focus on more strategic stuff.
Exactly. Automation can really boost your efficiency and make things more accurate. Tools that automatically patch systems, configure firewalls, even detect and isolate those compromised virtual machines. It's like having a whole team of robots working 24/7 to protect your environment.
I like the robot analogy. But we still need skilled humans to manage all those robots, right?
Yeah.
Someone's got to program them, make sure they're doing the right thing.
For sure. Investing in a skilled security team is crucial. They'll be the ones designing your security architecture, implementing those tools, and responding to any incidents. And remember, the bad guys, they're always coming up with new tricks, so ongoing training for your team is super important. Keep their skills sharp.
Got to keep those security knights trained and ready for battle.
Couldn't have said it better myself. And one final tip. Never underestimate the power of good documentation.
Ah, documentation.
Right. Document all your policies, your procedures, those configurations, everything. It helps you stay consistent, troubleshoot issues if they come up, and prove that you're compliant with regulations.
Documentation, the unsung hero of security.
So true. Well, I think we've covered a ton of ground today, from the nitty-gritty of hardware all the way to the big picture of automation and documentation.
It's been a real deep dive.
Yeah.
I feel a lot more prepared for that CCSP exam now. What would you say is the most important takeaway for anyone studying for the certification?
I'd say the key is to think about cloud security holistically. Understand those layers, the technologies involved, the shared responsibility model. And remember, it's not just about stopping the bad guys, it's about building a secure and resilient cloud environment that helps your organization achieve its goals.
It's not just about defense. It's about enabling the business to thrive in the cloud.
Exactly. Finding that sweet spot between security and functionality. And as you continue your CCSP journey, never stop learning. The cloud is always changing, so stay curious and keep those learning wheels turning.
Great advice. Thanks for joining me on this deep dive. It's been a pleasure.
The pleasure was all mine. And to all our listeners out there, best of luck on your cloud security adventures.
And that's a wrap for this episode of The Deep Dive. We'll see you next time for another exciting exploration of cloud security.